Welcome back. I'm happy to be back with you again. And this afternoon we are going to look at Boyles' law. It is a very important gas law. It's very simple. Boyles' law is as easy as ABC. And after this lesson, you will discover that with some simple tips, you can answer the questions better and you can understand Boyles' law better. At the end of this lesson, you will be able to understand Boyles' law and you will be able to solve calculation problems involving Boyles' law as well. And once again, I would like to remind all of you, to do better in physics, to understand physics better, do not just read your reference books. It will not help you very much. What is more important is that you must write down your answers. You must answer questions again and again. Pick up questions and answer the questions, like what I am doing now with you. Now look at this question. The diagram shows an air bubble formed by a diver. What is the volume of the air bubble at Y if its volume at X is 6 centimeters cubed, or 6 cubic centimeters? Assume the atmospheric pressure is equivalent to 10 meters of water. So our calculation problem is, find what is the value of the volume at Y. That's it. What is the volume of the air bubble at Y? We are given these few pieces of information. We are given these values. So I will guide you what to do. Now let's take a look at this question. In fact, there are many parts to answering this question which is very, very important. Number one, look at the last statement of the question. It says, assume the atmospheric pressure is equivalent to 10 meters of water. So even before we look at Boyles' law, we have to understand this physics concept first. Alright, now let me draw again. I'm sure you like my drawing, isn't it? Cartoon drawing. Alright, so let's say I have a tank of water. Alright. You just imagine, this is a swimming pool. A very deep swimming pool, alright? Okay. Alright, this is my swimming pool. Okay. Now, at the surface of the water, it is important to note that, alright, let's say this is the surface, okay, of the water. Alright. Now, at the surface of the water, what is the pressure? What is the value of the pressure? At point, I call it, okay, let's say P. No, P is not so good. Just call it A. Alright? Now, at point A, the atmospheric pressure acting at point A is 10 meters of water. In other words, there is a value even at point A. Alright? So at point A, what is the pressure at point A? It is actually atmospheric pressure. Alright? And this atmospheric pressure is 10 meters of water. Now this is the most important point in this question, apart from Boyles' law. Many students make a mistake in this question because they did not get this clear in their minds, or they did not understand what I have just said. Alright, I'll give you another point. Let's say I choose point B here. Alright? And let's say this is 8 meters deep. From the surface of the water to point B, 8 meters deep. So now my question is this. What is the value of the pressure at B? Alright, what is the value of the pressure at B? What is the value of the pressure at B? I'll just write it here. Now, in terms of the units of meters of water, the pressure at B is equal to the atmospheric pressure plus the pressure due to the column of water. Alright, this is, let's say we call it water. So it is atmospheric pressure plus 8 meters of water. So what is the value? It is 10 meters of water, alright, plus 8 meters of water. Do you get it? In other words, it is atmospheric pressure plus 8 meters of water. So the total would be 18 meters of water. Alright, so PB, I write it here, PB, the total value would be 18 meters of water. The units is very important. So once you get this clear in your mind, you can attack the question. Alright, let's go to the question now. Okay. Now in this question, we are given a few values. Alright. Let's write down what we are given. The volume at X is 6 centimeter cube. So I write down volume at X is 6 centimeters cube. Okay. What else? What about the pressure at X? Now look at X. It is here. Okay. Let me highlight it so that you can see it easier. Okay. X is there. So what is the pressure at X? Many students make the mistake by saying that the pressure at X is 5 meters of water. Now just now I explained it is not correct. The pressure at X is 5 meters plus 10 meters of water. Because we have to add in the atmospheric pressure. So what is Px? It is 10 plus 5 meters of water. Alright. Okay, not enough space. Get it? So I write it again. Total is 15 meters of water. That is pressure at X. Now what about pressure at Y? The pressure at Y is 2 meters deep. So it is 10 plus 2 meters of water. So what do I get? I have 12 meters of water. Now you must have taken note that every time I write down numbers, I write down the units. Every step in my working, I write down the units. Because units plays a very important role in your understanding of physics. If you drop the units, you will see only numbers, you will not understand it. Okay, so now let us take a look at our formula. The formula page. Here we are. PV over T equals to constant. So in this case, we have pressure varying or changing with volume. And here we assume that the temperature is constant. So in other words, PV equals to constant. Alright. So we know that PV equals to constant because T is constant. In other words, I will write down Px Vx equals to Py Vy. And what do I need to calculate? What is the volume of the air bubble at Y? I want to find Vy. So Vy gives me Px Vx divided by Py. Alright, let's continue. So what is Vy? Now Px is, let's take a look at the value here. Px is 15 meters of water. Alright. Px is 15 meters of water. Let me write it again. Px is 15 meters of water. I write the units. Multiplied by Vx. Vx is 6 centimeter cube divided by What is Py? Py is 12 meters of water. Okay. You will notice that meters of water up in the equation, or rather in the fraction, we can cancel it off. Okay, my final answer would be in centimeter cube. Alright, so what do I get? Here, I prefer to do manual. I will get 7.5 centimeter cube. So that is my answer. So the volume of the bubble at Y would be 7.5 centimeter cube. Because as it goes higher, as the pressure gets smaller, the volume gets bigger. Alright? Now, to summarize this whole question and the whole question of Boyle's law, I would like to advise you to write down the statement of Boyle's law. Write it down in full, what it says. And secondly, look for questions like this and answer the questions. And once you answer many questions like this, your understanding, your concept of Boyle's law becomes more and more steady, and you become bulletproof. Alright, and I'm sure you have learned a lot in this short lesson. So, once again, you have understood Boyle's law from a slightly different angle again, and you are able to solve calculation problems in Boyle's law. Alright, so with this, I would like to wish you all the best in your studies in physics in your examination. Thank you very much, and may God bless you. See you again the next round.